In 2013, Explorer 1 accomplished a surprising achievement by becoming the first human-made object to enter interstellar space. This extraordinary accomplishment happened 36 years after its takeoff from Earth. The space apparatus is currently 14.5 billion miles from Earth, requiring about 2 days to collect and transmit messages. NASA engineers never hypothesized that Explorer 1 would continue its space investigation for almost 50 years. In 2003, Explorer 1 identified 500 unidentified objects moving through space, igniting immense conversation. Notably, popular podcaster Joe Rogan joined the discussion to shed light on the disruptive implications of this uncommon discovery. These strange things could have been made by extraterrestrial creatures or simply been a problem with the space apparatus. The mystery has fascinated researchers for a considerable amount of time, but recent extraordinary encounters in space have sent shock waves through the scientific community. These encounters might reveal insights into the age-old question of the existence of extraterrestrials. Joe Rogan, a well-known podcaster and reporter known for his distinct interest in examining extraterrestrials and the possibility of advanced civilizations, has previously hosted guests like David Grush and Avi Ben to explore the potential for life beyond Earth. The notable Explorer 1 mission was conceived in the 1970s when NASA researchers had the opportunity to truly grasp the vastness of our immense universe. It all began with an unlikely alignment of Jupiter, Saturn, Uranus, and Neptune, the 4 largest planets in our solar system. A young PhD student named Gary Flandreau discovered a remarkable celestial occurrence that would direct space exploration in the late 1970s and early 1980s. The 4 planets aligned in a stunning configuration resembling pearls on a great necklace, with Earth nestled among them. This discovery sent waves of enthusiasm throughout NASA, presenting a unique opportunity to streamline the trajectory of a spacecraft by cleverly utilizing the gravitational pull of each planet. Estimated by Flandreau during flybys, the assistance of gravity provided by the giant planets could shorten the flight time from Earth to Neptune from 30 years to only 12 years. However, this celestial alignment occurred only once every 176 years, prompting NASA to embark on an ambitious mission to capitalize on this once-in-a-lifetime opportunity. Explorer 1 and Explorer 2 were twin spacecraft launched in 1977 to investigate the mysteries of the solar system. Launched 15 days apart, they became integral components of NASA's Explorer space program, a demonstration of humanity's insatiable curiosity and quest for knowledge. For nearly 50 years, Explorer 1 has been transmitting valuable data back to Earth through NASA's Deep Space Network, bridging the gap between our earthly existence and the secrets that lie beyond. Currently, Explorer 1 is 24 billion kilometers away from Earth, standing as the farthest human-made object from our planet. The spacecraft was meticulously designed and built by NASA's Jet Propulsion Laboratory and began its historic journey from Launch Complex 41 at the Air Force Station in Cape Canaveral, propelled by a Titan IIIe launch vehicle. One key feature of Explorer 1's launch was the presence of dual redundant computer systems. Both Explorer 1 and its twin Explorer 2 were equipped with 2 sets of command computer subsystems: Flight Data Subsystems, FDS, and Attitude and Articulation Control Subsystems, AACS. This redundancy ensured smooth transitions between systems and the ability to activate dormant computers when necessary, thereby extending their lifespan. The computer systems on board the spacecraft were arranged as a distributed system with 3 redundant sets of computers, ensuring that if one system failed, the others would seamlessly take over, preventing critical failures. Power management is a crucial aspect of maintaining the operational integrity of Explorer 1, especially as the spacecraft's increasing distance from the Sun poses significant obstacles to utilizing solar energy. Engineers had to devise innovative ways to monitor and optimize power usage, including implementing specific shutdowns of non-essential systems. In summary, Explorer 1 and Explorer 2 have been instrumental in uncovering the secrets of the nearby solar system and interstellar space, providing pivotal insights into the vastness of space and the unsolved mysteries that lie beyond. Explorer 1, a space probe that has defied all odds, continues to transmit vital information nearly 50 years after its launch. Initially expected to last only 5 years, Explorer 1 has been equipped with a wide array of scientific instruments and subsystems. These instruments were strategically placed on the spacecraft's body, which contains an incredible 65,000 individual parts. One of the enduring instruments on both Explorer 1 and Explorer 2 is the low-energy charged particle detector. This instrument boasts 3 sets of sensors that measure the number and speed of low-energy particles that hit it. It continuously monitors high-energy radiation and particles coming from the Sun, planets, and interstellar space. The Cosmic Ray Detector, a companion instrument, actively searches for high-energy particles from the Sun and other celestial sources. The Plasma Wave Subsystem, which includes 2 extended radio antennas arranged at right angles to each other, serves as a critical tool for measuring the electric field components of potential waves encountered at the outer planets. However, its role has evolved as the explorers ventured into interstellar space. Over the years, engineers have made remarkable technical advancements and improvements in power management techniques, including improved power distribution, enhanced battery charging methods, and advancements in power regulation and control. Explorer 1's transmissions continue to provide essential data, demonstrating the dedication and creativity of the engineers and scientists who have worked tirelessly to keep it operational. The Explorer missions, initially designed to study the magnetic fields of outer planets, have undergone significant changes as they journey into interstellar space. The magnetometer, originally focused on studying the magnetic fields of outer planets, now plays a crucial role in examining the transition region between interplanetary and interstellar space. This instrument helps analyze the boundary where the Sun's magnetic influence gives way to the magnetic field of interstellar space. The Plasma Science Instrument, which analyzes low-energy particles within plasma, is currently operational only on Explorer 2. This instrument embodies NASA's ongoing scientific investigation. The organization deliberately deactivated radiometers on both spacecraft after 21 years of operation, and instruments that were no longer needed were permanently turned off. The power source for each spacecraft consists of 3 radioisotope thermoelectric generators, RTGs, which use the heat generated by the radioactive decay of plutonium-238 to produce power. As plutonium-238 continues to decay, it will eventually be unable to provide sufficient power, resulting in the suspension of everything, instruments to extend the operational lifespan of both spacecraft until 2027. The Explorer team is employing careful power management strategies. Each spacecraft possesses transmitters to maintain communication with Earth. The primary transmitter emits about 20 watts of power. However, the signal strength from Explorer 1 reaching Earth is 20 million times weaker than that of a modern wristwatch battery. Explorer 1's journey through space has not only expanded our knowledge of the solar system but also provided crucial insights into the bubble of the heliosphere's nature, charged atoms that surround the Sun. As Explorer 1 moved further from the Sun, it began to encounter different environmental conditions than those experienced by previous spacecraft. Perhaps one of its most significant contributions was its role in mapping the heliosphere structure and its boundary, known as the heliopause. This boundary marks the transition between the solar wind and the space between stars, where the Sun's influence wanes and material from other stars begins to dominate. By sending back data from its plasma wave instrument, Explorer 1 has helped scientists better comprehend plasma's behavior in this transitional zone. This information is essential for understanding how cosmic rays from outside the solar system interact with the heliosphere and how these interactions affect space weather. Such insights are vital not only for space research but also for securing future spacecraft and astronauts from harmful space radiation. Another key aspect of Explorer 1's mission is its contribution to magnetic field research. As the first explorer crossed the boundary into interstellar space, it provided the initial precise measurements of the magnetic field beyond the Sun's influence. These measurements have been instrumental in enhancing our comprehension of the magnetic environment of the interstellar medium. The data collected help scientists model the magnetic interactions between various parts of space and understand how these interactions influence large-scale phenomena. Explorer 1's longevity and continued data transmission have also contributed to a better understanding of the properties of interstellar dust. The spacecraft's dust detector has been crucial in measuring the density and speed of interstellar dust particles. These measurements provide valuable information on the composition and distribution of dust in our galaxy, which, in turn, influences theories about star formation and the evolution of the medium between stars. The spacecraft's ongoing mission has also shed light on the advancement of technology used in space exploration. The engineering achievements of Explorer 1's mission have set a benchmark for future deep space missions. The innovative design and resilience of Explorer 1 systems have influenced the development of subsequent spacecraft, illustrating how engineering solutions can extend the life and effectiveness of space missions far beyond initial expectations. Moreover, in addition to its scientific achievements, Explorer 1 carries a symbolic message for any potential extraterrestrial civilizations. The Golden Record, containing images and sounds intended to represent the diversity of life and Earth's culture, serves as a universal greeting and a testament to humanity's desire to connect and share its presence with the universe. This message and the spacecraft's data represent a monumental step in humanity's quest to explore the universe and engage with intelligent life beyond our world. Overall, the Explorer missions have made significant strides in their exploration of interstellar space and the mysteries surrounding the discovery of 500 unidentified objects. Explorer 1, a space probe, has identified 500 mysterious objects in the depths of space, sparking a wave of concern among scientists. Initially, data sent back to Earth was distorted, resembling a garbled message from the universe. NASA's Jet Propulsion Laboratory was baffled by the confusion and found that the Attitude Control and Guidance System, AACS, had switched to using a malfunctioning onboard computer that had been dormant for years. This caused distorted telemetry data. NASA engineers quickly fixed the issue by changing the AACS so that it could send data through the correct computer. Uncorrupted data from Explorer 1 is now streaming back, but the question remains: what caused the AACS to use the wrong computer? NASA researchers have yet to provide a definitive answer, but have proposed a theory suggesting that the AACS received a corrupted command from another onboard computer. Susan Dodd, project manager for the Explorer interstellar mission, revealed that a comprehensive memory readout of the AACS would be conducted, followed by an extensive assessment of its activities to determine the root cause of the telemetry issue. Several factors could contribute to the anomaly, including the environmental conditions of space, cosmic radiation, temperature changes, and exposure to micrometeoroids such as dust, asteroids, and their debris, as well as comets. As Explorer 1 ventures into interstellar space, its plasma wave instruments have consistently detected the effects of dust particles. Due to their high spiral speed, when a dust particle collides with a spacecraft, it disintegrates and ionizes, creating a growing plasma cloud that triggers a voltage pulse in the spacecraft's plasma wave antenna. While other conventional hypotheses have been proposed to explain the telemetry anomalies in Explorer 1 systems, one possibility that has captivated public interest, and belongs to the universe of science fiction, is the involvement of extraterrestrial beings. However, this theory is highly speculative and not widely accepted within the scientific community. The idea of intelligent extraterrestrial life has intrigued scientists and space enthusiasts alike. Well-known podcaster and media figure Joe Rogan has explored this topic through conversations with scientists and UFO enthusiasts, particularly David Grush, a former Air Force intelligence officer and representative of the National Awareness Office for Unidentified Aerial Phenomena, UAP. Their discussions have fueled interests surrounding the anomalies observed in Explorer 1's data. Rogan believes that the universe is vast, containing billions of galaxies, stars, and potentially even more planets. The possibility of intelligent civilizations elsewhere in the universe raises fascinating questions about their potential interactions with humans. If these extraterrestrial beings were to encounter Explorer 1, they might have observed the spacecraft as it moved through the universe and chosen to investigate it, perhaps out of pure curiosity. This scenario suggests that the anomalies could be their way of sending an interstellar message, a form of extraterrestrial greeting. The Golden Record, a surprising artifact aboard Explorer 1, serves as an interstellar time capsule designed for any intelligent beings that may come across it. If extraterrestrial beings were able to access the Golden Record, they would interpret an abundance of information about Earth's cultures, languages, and the staggering variety of life on our planet. This raises fundamental questions about how they would interpret our music, art, and scientific knowledge, and what they might make of our dialects and technological advancements.